we have a 6 by 24 inch piece of metal. So here's my rough sketch. 6 inches wide, 24 inches long. And then they're cutting squares from each corner. So I'll make some dotted lines to show that we're cutting some squares here. And then it says open top. So that means you cut these squares, you fold it on these dotted lines. And so this is going to be the width, this is going to be the length of this rectangle, and then these determine how high the rectangle is. You know, the side length of that square that we cut is going to determine h. So let's call this h, that'll be the height of the rectangle. And then the width of the rectangle depends on how big of an h we choose. It's not 6 because we're not using the whole thing. It's 6 subtracted by 2 of those h's, right? Because if this is h, then this is h. So we've got 2 h's that we need to subtract away from 6. And then we can do the same thing down here. It's 24 minus 2h for this dimension here. All depends on that height. Okay. Now we got the length and the width defined. This is the length, this is the width. Actually, I wonder when you type this in WebAssign, I mean, it says 6 by 24. Is that length by width, or is that width by length? We'll have to mess with that at the end. Oh, it says right here, the width be determined by the 6-inch side. This is going to be our W. W equals 6 minus 2h. Okay, we'll just keep that in mind for the end. But anyway, to maximize the volume, we first need to come up with a function for the volume. Volume is the length, which is 24 minus, oops, I lost my h. Length times the width times the height. And the height is determined by h. And so if you expand this, multiply those two parentheses, so we got 144 minus 48h. I'm just multiplying the two parentheses together. So minus 12h plus 4h squared. That's what the two parentheses are when you multiply them. You got to multiply everything by h. So when you distribute that h, you get 144h. This is minus 60h, so now that's going to be minus 60h squared. And then this is plus 4h cubed. Now we have something to maximize. Okay, to maximize or minimize something in calculus, you want to take the derivative and set it equal to 0. So I'm taking a derivative with respect to the height. And I'm going to set that equal to 0. That finds all critical points. They're potential maxes or mins. They're not guaranteed to be maxes or mins. We have to test them. They're not guaranteed to be global maxes or mins. We have to test them. Okay, so to solve that equation, I'd factor out a 12 from everything. And then I can factor this. You could rearrange it as h squared minus 10h plus 12. We're looking for two numbers that multiply to be positive 12 but add up to be negative 10h. Add up to be negative 10. So the pair of numbers we need are... Oh, actually, can you? I was going to say 6 and 4, but obviously that doesn't multiply to be 12. Two numbers, 3 and 4... 6 and 2. No, you can't. So we got to use the quadratic formula. We're trying to solve this equation. So we factor out the 12. That makes it a little easier to digest, but the key is now to find out what it takes to make this equal to 0, and we have to use the quadratic formula for that. So negative b, this is our b, 1 is our a, 12 is our c. So negative b plus or minus the square root of b squared minus 4 times a times c, that's all over 2 times a. So 4 times 12, 48, so we got 52 inside the radical. And square root of 52, I think we can simplify. Divisible by 4, it is. You can take out a 4. And that's good because everything's being divided by 2. So 10 divided by 2 makes 5. The square root of 4 is 2. So 2 divided by 2 makes nothing. So 5 plus the square root of 13 is our height. And you'd want to test that by checking a value to the right or to the left. Like you could plug in h equals 4 or h equals, I dropped my minus symbol over here. So 5 plus square root of 13, 5 minus square root of 13. These are the two potential maxes or mins. Let's go back. So here I forgot my minus sign. So these are the two potential maxes or mins. So we got 5 plus square root of 13. That's around 8.6. Let's make this be 0. So here's 8. So there's one of our potential maxes or mins. And then if you do 5 minus the square root of 13, 1.39 is our other one. So here's 1. Here's our other potential max or min. This is 5 plus square root of 13. This is 5 minus square root of 13. If you want to test values between those, let's try if we plug in 2 into our original function for the volume. If I plug 2 in here, I get 20 times 2 times 2. So I get 80. This is volume, so I should say V of 2 is 80. I need to check that and compare it to V of 1. If I plug in, V of 1 point something, right? 5 minus the square root of 13 is what I'm testing. This is our critical point. Let's see if that value is less than 80, then we know this is the only chance this has of being a minimum because it's below the value a value that's to the right of it. So let's try plugging in that decimal number. Okay, so plugging that into our volume equation. Multiply that by 2, subtract that by 24. And it's positive just because of the way I did it. Okay, so 21.2111. 21.2111. We're going to multiply that by 21.2111 and then multiply that by our h. Okay, so this one is 94.97, approximately equal to 94. So it's bigger. This looks like it's going to be a max. Let's check out this value. If I was to plug in 5 plus the square root of 13, let's see what we get for a value. So square root of 13 plus 5. If I plug this value into my volume equation, I'm going to get something negative. Look right here. If you do 2 times this h and then subtract it from 6, you get a negative value for this term. You're going to get a positive and positive value here. So it's going to give us a negative volume. So this is a critical point, but it gave us a negative volume. So that's why you've always got to test your critical points. So the only max we have is 5 minus square root of 13. So that's our height, is 5 minus square root of 13. To find out the width, you're just going to plug in 5 minus the square root of 13 into the expression that we created for the width. I don't know what I clicked. Something not good. Okay, so 2 times 5 is 10, so this is negative 4 plus 2 square roots of 13. I think we could just leave it as that. Negative 4 plus 2 square roots of 13. Or you could write it as 2 square roots of 13 minus 4. That would be a positive number, I think, because if you take the square root of 13, multiply by 2, and then add negative 4. Okay, so we get a positive value for the width. That's our width. And then our length is 24 minus 2h. Again, you would just plug in what we found to be the maximum. So 24 minus 10, and negative times negative makes a positive. So there is our length.